So for this slide, this is number 20 on page 63, and this should help you do problems 11 through 21 odd. Again, you have odd problems, so you just do 11, 13, 15, 17, 19, and 21, and the answers are available for you. Please look those up. Okay, part A says to find the domain and range. So I've already showed you how to get things started. We're going to do set notation, so it says x such that. I can also show you interval notation. So I saw in a book once that it was nice to think of x as going from right to left, and it's as if you just follow it with kind of like a laser. So it starts at -3 and just goes on, and this arrow really shows that it goes on and on to positive infinity because it's going to the right, which is positive. So we're going to say that it goes from -3, and this shaded in circle says it contains 3, so we're going to say equal to x, and then it's less than or equal to, and we'll say positive infinity. Interval notation just shows the interval that this is on. So if you wanted to do interval notation, you would do a bracket because it includes -3, comma, positive infinity. And if you ever have infinity on either end, you always show this because there's really no containment for that. For the range, you're going from low to high. So from low on the y, it really doesn't go below this. But then again, that arrow shows that it's going to go up forever. So it doesn't go below where y equals 0, which is right here on the graph, and then it goes up forever. So it's going to look similar, only our lower bound is 0. And then we're going to do positive infinity. In set notation, 0 is included, so that's going to be a bracket, comma, positive infinity. And that's just a parenthesis to close it. So for part B, and I know before I called the range part B, that was really all part A. So they're asking for the intercepts. So this is where it's going to intercept the x-axis, and you can see where I'm circling these two places. It doesn't have to cross, it just has to meet it, or the y-intercept right here. So let's list those points. So this point right here in pink is going to be at -3, 0. And then we'll put the other point in black. That's at 0, 2. And our third, and that's our y-intercept, and our third intercept, I'll put this in blue, is at 2, 0. I'm going to double check because I made such circles, so 3, 2, and 2. Yep, so those look good. That's part B. So part C asks for symmetry, and it's not symmetrical. If I cross a line down here, this side does not match up with this side. It is not symmetrical if we go like this, because there's nothing below that. And there's not a circle around it, or I can't rotate it, so there is no symmetry. Oh, and I apologize. It also, right away it asks, determine whether the graph is a function by using the vertical line test. So for that, even before I start A, B, or C, if I'm making a vertical line, it crosses it once, it crosses it once, it crosses it once. So for the start, I would say this is a function. You could say it passes the vertical line test. And that's it for number 20. So I'm also going to do number 22. I'm going to do this one right. So right away it asks if it's a function using the vertical line test. So again, if I'm just making a straight up and down line, it crosses once. If I do it here, it crosses once. And even though this gets very vertical, it's still only crossing once. So I'm going to say this is a function. by the vertical line test. So again, for the domain, excuse me, I'm sweeping left to right. So this really is going to go on and on forever this way. And this arrow right here makes me know it's going to go on and on forever this way. So it's really the set of all real numbers. So I can just go like this. I could do from negative infinity to infinity, and I'll do that in interval notation. So interval notation will just go from negative infinity to infinity. And again, you just use normal parentheses when it's infinity on either end. For the range, we're going from low to high. So there is a high point. So it's going down forever, and those arrows point down. But then when I think of how high it goes right here, or this y value is 5. So it's going to start at negative infinity. And then we're going to 5, and that shaded in circle says that 5 is a solution. Interval notation, this is my lower bound, so I'm just going to use a parenthesis, comma, my upper bound, and 5 is contained, or it includes 5, so that's a bracket. B asks for the intercepts, so I'm just going to list them. So here's an intercept. So intercepts at -1, 0. And then I'll do the other one here. So that's at 2, 0. And then my y-intercept crosses at 4. So that's my x value is 0, 4. Again, this is asking about symmetry, and it does not reflect evenly over this line because there's too much on this side than there is on this side. It doesn't reflect evenly here. And it doesn't reflect around. If we wanted to be specific, there's always a line of symmetry for a parabola. So there is symmetry at the line y, that's where x crosses. So x equals 1. But they're not asking for that. This directions just say x-axis, y-axis, or the origin. So there is symmetry here, but they're not asking for that. So you could also say no symmetry. Noticing x equals 1 is kind of like a bonus. All right, so that's 20 and 22. Again, you should be able to do now 11 through 21 odd.